Good day, guys. You are welcome back to Idowu Math class. Today we are going to an important topic in UTME. The topic is loci. Loci is the plural form of locus. And what is a locus? By the way, a locus is a set of points that form a shape in geometry. A set of points that form a shape in geometry. And I'm going to take you through 6 different loci in this lecture. Let's follow and look into them one after the other. Number 1 we are going to look into is locus of points equidistant from a fixed point. The locus of points that is equidistant from a fixed point is said to be a circle. This is what we mean. Let's say this is a fixed point where I dot here is a fixed point. The locus of points equidistant from this fixed point will be a circle. What is the meaning of equidistant? That have equal distance. Now let's say this point A, is having equal distance with another point B. Let's say this point B is the same distance from the fixed point. Another point C is having the same distance from the fixed point. Another point is having the same distance from the fixed point. If you line them up like that, the same distance all around this fixed point, you realize you form a circle. A circle. By the time you join them together, you form a circle. Therefore, the locus of points equidistant from a fixed point is called a circle. That is a way of defining circle. Let's consider example 1. In this example 1, this is UTME past question. The locus of points that is equidistant from a fixed point is a, what is it? Option A, circle with that fixed point as center. Option B, line passing through the point. Option C, line round to the point. Option D, cube with the point as a center. According to what I've just explained and what you can even see on the board, option A is the correct answer. Circle with that fixed point as center. Let's consider example 2 under this first locus. The locus of a dog tethered to a pole with a rope of 4 meters is a what? Option A, circle with diameter 4 meters. Option B, circle with radius 4 meters. Option C, semicircle with diameter 4 meters. Option D, semicircle with radius 4 meters. Definitely, you know the correct option is circle with radius 4 meters. How? Let me explain to you. The locus of a dog tethered to a pole, just say tied to a pole with a rope of 4 meters. Let's say this is the pole. This is where the pole is. And the rope is 4 meters. 4 meters. That means this is the neck of the dog. This is the neck of the dog. Don't mind me drawing something like this. That means this is the neck of the dog with the rope 4 meters. That means the region that dog can cover, if it chooses to be roaming around, the region the dog can cover is the extent of the radius of that place. You see, the radius 4 meters is the extent the dog can go. If the dog chooses to come like this, the rope will be moving alongside. The rope will be moving alongside like that, and the dog cannot go further than that. And this shape made by the merry-go-rounding of the dog will be a circle. That is why the correct answer is option B. And that circle will always be of radius 4 meters. That is it. Now we move to the second locus, locus 2, by my own arrangement. What kind of locus is that? Locus of points equidistant from a straight line. Locus of points equidistant from a straight line. What does it mean? When you have locus of points equidistant from a straight line, it refers to a pair of parallel lines, each on either side of the straight line. This is what I mean. This is a straight line. That straight line, any locus of point that will be equidistant from that line will be a pair of parallel lines on either side of this straight line. You know, we say they are equidistant. They have equal distance. Now, let's take a distance. Let me take 5 meters. From this end, take 5 meters. If you are using compass, practically, let's say you put the mouth of your compass at this edge and you mark your 5 meters up here. Mark it down as well. Come here to the other end. Put the mouth of the compass there with the same distance, 5 meters you have measured on your compass. Mark it up. Mark it down. Having done that, take your long ruler. Use your long ruler to align the arc and draw a straight line along the head of the arcs. Also do the same thing here. Use your long ruler to align the head of the arcs. Draw a straight line along that. I hope you get what I'm trying to demonstrate. This line will be parallel to this line and also to the original line at the center. And the two lines, they will have equal distance from the original line at the center. The distance between this line will be exactly the same as the distance between this line. Equal distance. Do we understand? And that is it. So anytime you hear the locus of point equidistant from a straight line, a single straight line, then it refers to a set of parallel lines, each on either side of the straight line. So come to this example. This is a question from UTME past question. It is as straightforward as you will see it now. The locus of a point which is equidistant from the line PQ. You know, line PQ, just any, if you name it PQ. Just what I've explained here. Just like you call this P, you call this Q. It's a line PQ. Forms a what? Option A, circle center P. Option B, a pair of parallel lines, each opposite to PQ. C, circle center Q. D, perpendicular line to PQ. I've just explained this now. You can see now that the correct option here is option B. A pair of parallel lines, each opposite to PQ. That is the answer. Let's consider example 2 under locus 2. The locus of a point which is 5 centimeters from the line LM is, don't forget, in this case, we are given the actual distance 5 centimeters. In the first example under this, we are not given actual distance. We are only told locus of a point that is equidistant, that is, that have equal distance. So it's the same thing. The equal distance in this case is the 5 centimeters. So in any case, anytime you hear locus of a point, equidistant or an actual distance is given from the line LM. The line LM is a line. From a line, a straight line, the answer should be a pair of parallel lines. One on this side, one on the other side of the straight line. So let's look at the options. Is a pair of lines on opposite sides of LM and parallel to it each distance 5 centimeters from LM. That is our answer without wasting time at all, because look at the other one. Line parallel to LM and 5 centimeters from LM. Line, just one line. But this is a pair of line. Do you understand? In a pair, we have two. So, but option B, only one line. No. Pair of parallel lines on one side of LM. On one side of LM makes that also to be wrong. On one, it should be on either side. One on this side, the other on the other side. But this says on one side. Pair of parallel lines on one side. That's wrong. So option D, a line distance 10 centimeters. That is far from the truth. So our correct option is option A. All you need is just to mastermind all these and you get them easily. We come to the third locus, which is locus of points equidistant from two intersecting straight lines. And that locus is said to be the angle bisector of the two lines. What do we mean? Just look at this. This is a straight line. Let me say AB. This is another straight line. I call it BC. You can see that the two lines AB and BC intersect at B. That is what we mean by two intersecting straight lines. They intersect here. Now, the locus of point equidistant from two intersecting straight lines. The two straight lines. These are the intersecting straight lines. Locus of point equidistant from the two of them will be the bisection of the angle they make. You know, it takes two lines to form an angle. Line AB and BC form this angle B at the center of them. So, the locus that bisects this angle into two equal halves will move from this point and go this way. This line is the locus we are talking about. And that line is the locus that divides, bisects the angle B at the center there into two equal halves. Such that the distance from that locus, this line, from this line BC is the same distance from this line, from the line AB at any point. At any point. You know, at this point, move from that line to line BC, also from the line to line AB is the same distance, equal distance. Come to this point as well, do the same thing. Move here, if you measure it to be a particular angle, it's the same thing to this part. Come here, do the same. It's going to be the same. That's why we say it's the locus of point that is equidistant from the two intersecting straight lines. So, come to the example 1. It has no working, just understanding. The locus of a point which moves so that it is equidistant from two intersecting straight lines is the what? Option A, perpendicular bisector of the two lines. No. B, angle bisector of the two lines. That is the answer. Option B. Let's consider C. Let's see what? Bisector of the two lines. Bisector. What kind of bisector? Bisector of the two lines. No. That's wrong. It has to be specific, like B, angle bisector. Look at option D, line parallel to the two lines. That's far from the truth. So the correct option is option B, angle bisector of the two lines. Let's consider example 2. This example 2 is a bit different, yet it is under the same content and context. Find the locus of a particle which moves in the first quadrant so that it is equidistant from the lines x equals 0 and y equals 0, where k is a constant. This is what we are talking about. Let's draw this Cartesian plane. On this Cartesian plane, this is the origin, 0. And the question says the particle moves in the first quadrant, that is at this point, along the positive axis. That is the meaning. Positive axis here, positive axis here. So in the region enclosed by the positive axis, this region, that is where the particle moves. And if that is the case, the locus will divide, will bisect the angle in between them. But the options are not left in that way, in form of angle bisector. The options are left in equational way. So what are we going to consider? We now consider that along this locus, x and y will always be equal. How? Whatever point we take from this point, trace it to y, whatever value it is the same value is going to be on x. If it is 5 here, it's going to be 5 here. From here, trace it up here. If it is 7 here, it's going to be 7 here. So if you trace it here, whatever it is here is what is going to be here. So x and y are always equal along that locus. Do you understand? Therefore, the answer will be that x is equal to y. That is, along that locus, x is always equal to y. Whether you put y first or you put x first, what is important is that they are equal to each other. But there's a clause here that where k is a constant, we want to factor in constant. And if you want to factor in constant, if you bring this here to be equal to 0, the answer will be option B. You use it to form this one-side equation. Answer will be option B. But there is mention of constant there. If you want to factor in the constant, then the only correct option we will have here is option D. I want to believe you understand. Because it is in the option D that you will factor in the constant and x and y will still be equal. Y having the negative sign here means that if you separate them to be on either side of the equation, y also will be positive, such that x will be equal to y. And the constant also will become positive. Do you understand?